So continuing the problems of joint probability distribution, here is an example. Find the joint probability distribution of two discrete random variables given by f of x comma y is equal to k of 2x plus y, where x and y takes the value between 0 to 2 and 0 to 3 respectively. Find the value of the constant k, find the marginal probability distribution of x and y, and show that the random variables x and y are dependent. I missed x here, so find x and y are dependent. Now it is given that x and y takes the value between 0 to 2 and 0 to 3, that is x lies in between 0 and 2. So in the table I let the x as 0, 1, 2, similarly y as 0, 1, 2, 3. Using these values of x and y in the given function f of xy, I get the different values of the tables as 0, k, 2k, 3k and so on. So before I proceed with the marginal distribution, find the row sum and the column sum, which comes to 42k. And as discussed earlier, this 42k should be always equal to 1, and from this we get k is equal to 1 by 42. So using the values of k, the marginal distribution of x and y will be x takes the value 0, 1, 2 and f of x is 1 by 7, 1 by 3 and 11 by 21. Y takes the value 0, 1, 2, 3 and f of y is 1 by 7, 3 by 14, 2 by 7 and 5 by 14. Now to show the random variables are dependent, it is enough to show there is at least one value such that p of xy is not equal to p of x into p of y. Now consider p of x is equal to 0 and y is equal to 1. The value from the distribution table is k and k is 1 by 42. Now consider p of x is equal to 0. From the marginal distribution table I have 1 by 7 and p of y is equal to 1, I have 3 by 14. So p of x into p of 1 will be equal, p of x is equal to 0 and p of y is equal to 1 will be equal to 3 by 98, which is not equal to 1 by 42. Therefore there is at least one value where p of xy is not equal to p of x into p of y. Therefore the random variables are dependent. Now consider one example wherein, depending upon what information has been provided, we need to find the joint distribution table. Here only the sample space is given with certain condition. Using those conditions, we need to find the joint probability distribution table and remaining the expectation, standard deviation, correlation, coefficient. But how to form the joint distribution table? Let me explain it here. Now the given condition is a fair coin is tossed thrice, that is a coin is tossed 3 times. The random variables x and y are defined as follows. Now x is equal to 0 or 1 according as head or tails occur in the first toss, and y is equal to number of heads. Remember, x will take the value as 0 or 1 when the first toss comes as head or tail, and y is strictly number of heads. So using this, the sample space will be formed as, first of all we need to find the total number of possible outcomes when 3 coins are tossed. That is, all the 3 coins can have head, 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 or all the 2 coins can fall as head and 1 tail. First head, second tail, third head. First head, then 2 tails. First tail, then 2 heads. First tail, head, then tail. 2 tails, then head, and all the 3 tails. Now, these are the total number of possible outcomes when 3 coins are tossed. Now, seeing these outcomes, we need to give the values of x and y. Now, x has been given as 0 or 1 if the first coin is head or tail. So, here the first coin is head, so x is 0. Again, here the first coin is head is 0. first coin is head 0, first coin is head 0. And in the remaining all the 4 cases, you can see the first coin is falling as tail. So it is given as 1, 1, 1, 1. You can see here x is equal to 0 or 1 according to head or tail occurs in the first choice. And y is only the number of heads. So in y value in the first case, since all 3 are heads, it is 3. 2 heads 2, again 2 heads 2, 1 head 1, 2 head 2, only 1 head 1, 1 head 1, and there is no head, so 0. So from this it's clear that x takes the value 0, 1 and y takes the value 0, 1, 2, 3. Now from this you need to form the joint distribution table. Now how to form the joint distribution table when x is equal to 0? Means how many values in the table we have got x as 0? 4. And what is the total number of outcomes possible? 8. So 4 by 8 is 1 by 2. And x is equal to 1 means how many times we have got x as 1? 4. 4 by 8 again 1 by 2. Then coming to y. Y is equal to 0 means how many times we have got y has 0? Only 1, so 1 by 8. Y has 1 is I have got 3 times, so 3 by 8. Y is 2 means again 3 times, 3 by 8. And y has 3 is only 1 time, so 1 by 8. Now so with the obtained values, the marginal distribution of x and y is given as told x takes the values 0, 1. So f of x is 1 by 2, 1 by 2. And y takes the value 0, 1, 2, 3. So f of y will be 1 by 8, 3 by 8, 3 by 8 and 1 by 8. Now using these two marginal distribution, we'll have to form the joint distribution table. Now the explanation goes as follows. When x is 0, y is 0. Now x is 0 means the first coin should fall as head. And y indicates total number of heads. So both 0 means it's not possible. So the value goes as 0. Now let me define this as x. This is y. Now when x is 0, y is 1 means the only possible is the first is head, the remaining is 2s, because even y also, y only one head I have to have, so it's 1 by 8. Now when x is 0, y is 2 means the possibilities are the first case should be head and there should be 2 heads in the outcomes. So these two are the possibilities. So it is 1 by 4, that is 2 by 8 or 1 by 4. Similarly, when x is 0, y is 3 means it should be all head, that is only one possibilities. It is 1 by 8. Similarly, when x is equal to 1, y is 0 means there should be no head and the first coin should fall as tail means this is only one option. So again 1 by 8. When x is equal to 1 and y is equal to 1 means the first one should be head and there should be only one head. That is the first one should be tail and there should be only one head, that is this case. THT and TTH. So I have again 2 by 8 or 1 by 4. X is equal to 1, y is equal to 2 means the first coin should fall as tail and I should have 2 heads. That is only this possibilities. And x is equal to 1 and y is equal to 3 means the only possibility is 0, because if the first x is equal to 1 means it should be tail and with 3 heads it is not possible, so the value goes as 0. So this will be the joint distribution of x and y. Then as usual, finding the covariance and the correlation, use the formulas and the marginal distribution tables wherever required, find the value. So we get, with all the values obtained, we get the correlation as -1 by √3. This example you can take it as assignment. Use the condition x is equal to 1, y is equal to 2. So this will be the value, x is equal to 1 and y is equal to 2. Likewise, for other condition, you can find the value.